there was another question that I think came from Twitter about the brightish white spots in that Hubble image everyone loves referencing.
Yeah.
If that is some kind of crater, and if that is digging up older material from beneath the surface that could be studied.
You know, it's a pretty good chance that that's what that is. So the white color, that just depends on the filter. It just means that it was bright here. So actually, so Ceres is a kind of carbonaceous asteroid, which means that it's actually really dark. So the actual color of Ceres is a lot closer to asphalt than it is to white. So it's actually a really dark asteroid. It has an albedo of around 10%. So it reflects 10% of the light that hits it, right? So that's way, way, way darker. So Vesta, for instance, is 40 to 50%. So it's actually really dark. So when you see a bright white spot in those images, it's not super bright white, but the fact that you're seeing a different color really tells us something. And when we look at images of Ceres in all different wavelengths, in the UV, in the visible, not so much in the IR, but when you see those, actually a little bit in the IR too, we see these kind of round circular spots, and what we don't know is what they are. They could be impact basins. They could be, maybe they're big, maybe they're chaos terrain like there is on Europa. You know, we don't know. What's kind of interesting is that, you know, if you look at that picture of Vesta, you know, there was a giant impact basin. We can actually see, we could see Rhea Silvia from a distance. We could see it with Hubble. We could see bigger basins that we thought were impact basins. We think we see them on Pallas, but we can't see any on Ceres. It's just perfectly round, down to 25 kilometers. Now, that doesn't mean that Ceres hasn't been hit by something that's bigger than 25 kilometers. It just means that whatever's going on Ceres has totally erased that, at least the topographic signature. So that's another reason that we think Ceres is icy. So what that may be telling us is, you know, maybe that's the center of an impact structure, and maybe that's a really cool place where the chemistry is going to be different when we get there with dawn. And it depends, you know, in some wavelengths, the spots on Ceres are dark. Some wavelengths, the spots on Ceres are bright. And none of the spots are the same in every wavelength. So spots in different areas on the surface, there's really no surface feature on Ceres that's really been detected because it's different in every wavelength. It's super exciting. We're going to learn so much when we get there. We don't really know why it's flat. If you want to go back to that spectrum I showed, one of the things that's really puzzling about the carbonaceous asteroids, so generically the C-type, the B-type, the G-type asteroids, these are terminology that astronomers use to describe these asteroids. If you'll notice, there's kind of almost a flat line from point 0.6 all the way across to 2.7. In Pallas's case, there's just a little bit of a dipping line. And we don't know why that is. When we look at Vesta, we see these deep absorption bands that tell us that its surface is covered in volcanics, covered in basalts. So those spectral features tell us that Ceres is kind of special, and there's a whole class of asteroids that are very similar in many ways to Ceres spectrally. They're different, but they've got that kind of flat visible infrared spectrum. And so we're really looking forward to figuring out what that means. So when we go to Ceres, what we're not only going to do is unlock a totally unique object in the solar system. It's actually, because of some of its similarities to other smaller asteroids, it's actually going to tell us what these asteroids were like early in the solar system history, what created all of that dark material out there, what that dark material might be. So it actually is kind of like, Ceres is like the gatekeeper to the history of water in the middle solar system. And really, I think it's going to be very compelling when we get there and can figure out what all these, what people have called boring spectra are actually telling us. So it may be ironic that the most boring spectrum in the solar system might actually be the most interesting. One of the ideas that's been kicked around is whether that's actually just a whole mixture of salts. So when we get to Ceres, might we see big circular impact basins with salt rings or something like that? That might be an indication that there was active water processing. Maybe that's why we can't see spectral features on Ceres with our ground-based telescope. So we don't know yet. It's going to be really exciting to see.